Here's our review guide for the Chapter 5 test review. Let's go ahead, we're supposed to simplify. Let's go ahead and do that. So we got 8 to the 4/3. Now our calculators could do this for us, but remember our calculators may give us decimals at some times. So let's just do this by hand. This means the cube root of 8. That's what the 3 means. And then take it to the 4th power. Well, to simplify 8, 8 is made up of 3 2s, so the cube root of 3 2s is just 2. So now it's 2 to the 4th power. And so we just have to do that either in our head. 2 times 2 is 4, times 2 is 8, times 2 is 16, or with a calculator. Problem number 2, we've got 4th root 208 over the 4th root of 213. What you may want to do at this point is right away we can check to see if 208 is divisible by 13. Turns out it is. Because they're both 4th roots, we can treat this as this 4th root of the quantity 208 divided by 13. And I grabbed my calculator. I did 208 divided by 13. It told me it is 16. And the 4th root is 16. I just did it over here. 2 to the 4th gives me 16. Therefore, the 4th root of 16 is 2. Problem 3. Okay. I've got the 5th root. And so you don't have to do this step here that I'm showing. But just to illustrate, this is the exact same problem. Now, we usually just don't do all this because it's a lot of work to show each one separately. But that's okay. You can if you want to. But what we have to do is just find the 5th root of 32. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 32 is a perfect 5th root. It's 5 2, so it's just 2. See, I can't do anything with the 5th root of x because there's only one of them. 5th root of y to the 6th. Okay, you're going to want to think of that as y to the 5th times a y, because there's 5 y's multiplied together, so a y can come out, but that other y has to stay in. And then for your z's here, you got 5 z's and you're taking the 5th root, so 5th root of z to the 5th is just z. Okay, so I simplified them individually, but at the very end we just wrap it all up. I've got a 2 on the outside, a y came out, and a z came out. And who is stuck underneath the 5th root? The x is, and this y is, right there. Now, essentially what we're doing here, if I wanted to do this without breaking it up like that, oops. And I'm going to point here so you can see it. Well, I do the 5th root of 32, that's just 2. The 5th root of x I can't do because it's only a single x, so the x stays in there. Then what I can do is basically you take 6 and divide it by 5, and 5 goes into 6 one time. That means a whole y gets to come out, but a y has to stay in because there's an extra y. And then I do the same thing with the 5s. I take this 5 and divide it by 5. It goes in there one time, so that is a whole x that comes out. Oops, not x, a whole z that comes out. So when you divide the exponent by your index here, every time it goes into it a whole time, that number gets to come out. 5 goes into 6 once, so a y comes out. That remainder of 1 is the y that stays in. Regardless of how you do it, here's where you end up. Let's look at number 4 here. 4 again, I'm going to change this to radical form. That's the cube root of negative 125. Now, what I've seen is a lot of students say, oh, you can't take the root of a negative. You can do cube roots, 5th roots, 7th roots, 9th roots of negative numbers, because negative 125 is 3 negative things multiplied together. It's an odd number of things. It's actually negative 5 times negative 5 times negative 5. So this simplifies to a negative 5, because that's the cube root of negative 125 squared then, or just 25. I don't know why my paper's all crooked here. So there would be our final answer for number 4. Let's take a look at number 5 here. 5 is a subtraction problem of radicals. To subtract radicals, they have to have the same radicand. One has a radicand of 5, the other has a radicand of 125, so we got to hopefully simplify the 125. See, 125 is 25 times 5. And I can square root of 25. The square root of 25 is 5, so that 5 comes out. It gets multiplied by the 2, and the 5 stays in. Now these are like radicals. So I got 12, take away 10. I've got 2 root 5s. Okay, you just add or subtract, in this case, the coefficients. The coefficients are the numbers in front of the radicals. 12 minus 10 is 2. Toughest one on here for simplifying. Oop, I'm going back. There you go. Number 6 is the toughest one on here for simplifying. Okay, remember we don't want radicals in the denominator. So, for example, if we had 2 over root 3, we multiply it by root 3 over root 3, it gives us 2 root 3 over 3. And we've eliminated the radical down there. That's called rationalizing the denominator. This is just an example of what we're trying to do in number 6. Now, in number 6, I would like to get rid of this radical down here, this guy, but I can't just multiply by root 3. You've got to multiply by the conjugate. The conjugate is exactly the same as what's down there, except it's got the opposite sign. So for us, it's 1 minus root 3. Now, on top, the math is easy. Distribute, distribute. In the denominator, this is a big distributing problem. 1 times 1 is 1. 1 times negative 1 root 3 is negative 1 root 3. 1 root 3 times positive 1 is 1 root 3. And we got a positive times a negative, that's negative. And a root 3 times a root 3, which is root 9. Let's just clean this up a little bit. So we got our 1 down there. Negative 1, positive 1, root 3s, they cancel out. So it's just minus root 9, but the square root of 9 is 3, so it's minus 3. So it's 1 minus root 3 over negative 2. Oops. You could also see this, negative 1 plus root 3 over positive 2. Either of those are the same. Okay, both correct. I'll zoom out here for everybody. Pay attention. And if it sounds like I'm talking to myself, it's because I will be. So number 7, we're supposed to take these two functions and do something with them. Here it says to add them. So our work looks like this. Start with what you're trying to find, f plus g of x equals, and I'm going to highlight these and kind of color code them for you. So here's my red function, and we'll call this one my blue function. And so I'm just going to add those two functions together, 3x to the 5/3, and it says add on the other function. The other function is negative 2x to the 5/3. Because these two x's are raised to the same exponent, that's very important. And it is because, like, if it's 2x cubed plus 4x squared, because those variables have different exponents, we cannot add those. Okay? It's only if they're like terms can you add them. To be like terms, you have to have the same variable, same exponent. Now, these two have that. I've got 3x to the 5 thirds. Take away 2x to the 5 thirds, leaving me with 1x to the 5 thirds, or just x to the 5 thirds. Now, they want us to check the domain for this. The domain, you got to watch out for square roots, because you can't do negative numbers. And you have to watch out for divisions by 0. Well, I don't have any square roots in this because these are all cube roots. Okay, I don't even have a division in here. There's no denominators at all. And therefore, there's no restriction on my domain, so I just say domain is all real numbers. Okay, so my final f plus g of x would be x to the 5 thirds with a domain of all real numbers. Here comes subtraction now. F minus g of x. And so again, using my color coding, that's 3 times x to the 5 thirds. This time minus, oops, let's do it in black there, minus negative 2x to the 5 thirds. Now, we get a double negative here, so it's going to be an addition problem. So it's 3x to the 5 thirds plus 2, so that's 5x to the 5 thirds. Again, we're doing cube roots, and we're not doing any division, so domain, all real numbers. Let's do a multiplication now. So we've got f times g of x. So in red, we've got 3x to the 5 thirds, and we have to multiply that by negative 2x to the 5 thirds. Now, with multiplication, we have a rule with that. As long as your bases are the same, you can combine them. So we're going to do, this is all multiplication. You can think of it like this if you want to. And we can multiply in any order we want. So we're going to do that multiplication. That's negative 6. And then when you multiply with that common base, you have to add your exponents. So I'm getting negative 6x to the 10 thirds. Again, I'm doing cube roots, so I don't have to worry about taking the square root of a negative or anything. I never did any division, so our domain, again, is all real numbers. So make sure you add the exponents when you're multiplying with common bases. If you ever forget that, think about like x cubed times x, or x squared times x cubed. That would be x to the 5th. You add the exponents together. Think of it as x times and x times x times x. And that clearly is x to the 5th. It's just harder to see that when they are these rational exponents. But the process stays the same. Add the exponents together. And finally for division, so we've got f over g of x. And we'll put our red one in the numerator, that's f, over our denominator, which is negative 2. So here, we can't do 3 divided by 2, just they don't divide evenly. I'm going to write that as negative 3 over 2, same thing. But then it's x to the, and the rule is subtract exponents for division. So that's negative 3 over 2, and that would be x to the 0 power, which is just 1. So this simplifies to negative 3 over 2. Domain for this, our domain should be all real numbers again because all the x's fall out. They don't matter. However, at the very beginning, we had an x in the denominator, so we can't ever let x equal 0 in this whole process. So we're going to say x cannot equal 0. But otherwise, any other number you plug in would be fine. And that would be our best answer. And we're done with number 7. On the flip side now, we're solving some equations. Note it says check for extraneous solutions. Basically, it means check your answers, make sure everybody works. First one here, number 8, is a radical equation. So our steps for solving radical equations are get the radical alone. Now, the radical here is the cube root. Sorry about that. Is the cube root of 2x plus 1. So you see that 4 sitting out front? We don't want that there. So we're going to divide by 4 on both sides, giving us the cube root of 2x plus 1 equals 5. Radicals alone, so we're going to cube both sides, giving us 2x plus 1 equals 125. We'll subtract 1 from both sides. That will make that 124. And then we'll divide both sides by 2. So I'm getting x equals 62 for an answer. Now let's check that really quickly. I'm going to do my check right here. I'm just putting in a 62 now, in for x, in the original problem up here. Okay, the right-hand side is just 20. There's no x, so I'm just seeing if the left-hand side comes out to a 20. If so, then 62 checks. So 62 times 2 is 124 plus 1. That's 4 times the cube root of 125. The cube root of 125 is 5. So it's 4 times 5, which is 20. And so indeed, 62 does check, and it is our correct answer. Let's erase some of this so we have room. All right, next problem. What do we have there? X equals 62. Next problem, radical equation again, but this time the radical is isolated on the left-hand side. There is a second radical, but it turns out to be isolated as well. That's really good news, because it's set up now, when I square both sides, 2x plus 5 must equal x plus 7. Now that makes sense, everybody. The radicand under here, 2x plus 5, better be the same number as x plus 7. Otherwise, when you square root them, they wouldn't equal each other. So that line in red makes really good sense. Let's get our x's on the same side. 2x minus x is 1x. Then let's subtract our 5. X is equal to 2. Now let's go up here and check that. We'll be erasing here. So we're going to check it in the original problem. So does the square root of 2, now x is 2, because that's what we're checking, plus 5, does 2 times 2 plus 5 square rooted, does that equal the square root of x is 2 and then plus 7? Left-hand side, that's 4 plus 5, or 9. Does that equal the square root of 9? The answer is yes. 3 equals 3, or root 9 equals root 9. So we're guaranteed that 2 is our solution. Last one in this section, we got 6x to the 2/3. So let's raise it to the reciprocal power, 3/2. And we're doing it to both sides so we stay balanced. Now, the reason we raised it to 3/2 is that's the reciprocal of 2/3, and 2/3 times 3/2, when you multiply reciprocals, you get 6 over 6. It just comes out to a 1. So it eliminates that exponent completely. Now on the right-hand side, we got 36 to the 3/2, so we want to simplify that. The 2 means to square root 36, and the 3 then means to cube that answer. So the square root of 36 is 6, so it's 6 cubed. So 6x, and we have to cube 6, so it's 36 times another 6. 216, I believe. 216, let's divide that by 6 now to get that x alone. Dividing by 6. 216 divided by 6 equals 30. I should have known that. Equals 36. So let's check that 36 now to see if that is indeed our correct answer. So I've got 6 times 36. That's what we think the answer is. And then I have to raise that to the 2/3. So that's this section right there. And if it gives me 36 for an answer, then I know I'm good. Well, I happen to know 6 times 36 is 216 because we just did that. And I know the cube root of 216. I know it is 6 times 6 times 6, so it's a 6. And then squared still, because we haven't done that squared right there. And 6 squared is 36. So, yeah, it checks. And we're guaranteed that was the correct answer. Number 11, find the inverse. We don't have to check to see if the inverse is a function or anything, so let's just start changing f of x. So I've rewritten the problem, but instead of f of x, I put a y in. Now I'm going to flip-flop my x's and y's. And my y, or my x becomes a y plus 10. You got a couple options here. I'm going to go ahead and subtract the 10 from both sides. And when you subtract that 10, you don't get anything funky. You get x minus 10 equals that negative half y. To get y alone, I'm going to do this. Instead of dividing by a half, I'm going to multiply by a negative 2. Because I know 2 times a half is just 1. And I know a negative times a negative is positive. So that's going to give me a positive 1y. That's exactly what I want. Now, since I take the right side times negative 2, I have to take the left side times negative 2, the whole side. So on the left side, we've got some distributing, negative 2x plus 20. On the right-hand side, that's that half times 2. It's negative times negative. It'll just be a positive 1. And so that's what y equals, 1y. Now let's write this thing in inverse function notation. Negative 2x plus 20. And we are done. Let's find the inverse on number 12 here. Y equals, switching y's for x's and x's for y's. That 5 is outside the radical. Okay, this is a radical equation. The y is underneath the root, so we have to get the radical alone. So first we're going to subtract the 5 away. So that's x minus 5 equals 3 root y. That root y is not quite by itself yet. Okay, it's 3 times root y right here. So we're going to divide both sides by 3. And so on the left side, it's x minus 5 divided by 3. On the right-hand side, the 3 would just cancel out, leaving you with just that root y. But now that the radical's alone, we can square both sides. It's going to be kind of a messy answer here. And so I get y equals x minus 5 squared. I'm going to write it this way first. X minus 5 quantity squared. And I'm going to put that 3, and I can square the 3, 9. So this is one answer that would work. We're going to run into a slight problem, though, as we start to flesh this one out. I am going to flip this whole thing around and write it as an inverse function. So f negative 1 of x equals x minus 5 quantity squared over 9. Now, one of the things that bugs me about this is that I know this is an x squared equation on top. In fact, this is x minus 5 times x minus 5 on top. So I'm going to go ahead and multiply that out. When I do this multiplication, remember, you're going to have to do all that distributing. There is a shortcut for this. but regardless, it comes out to that, all divided by 9. This would be that'd be a fine answer. You'd be okay there. This answer, though, is the one I wanted to look at because see how it is just an x squared equation? This is a quadratic. In fact, if I divided everything by 9, this is the quadratic in quadratic form, ax squared plus bx plus c. It's not very pretty. But since it is quadratic, I end up with the entire parabola here. And that entire parabola, if you think about it, is not going to pass the horizontal line test. So it doesn't have an inverse. But we just found the inverse of 3 root x plus 5 is this expression. So this expression should also be have 3 root x plus 5 as its inverse. So let's take a look at the original function, and let's see why this parabola is not exactly what we want for our inverse function. So I am going to pull up Desmos, and we'll take a look. So I've got Desmos open. I'm going to graph the original function now. So I go y equals, and it's 3 square root x. Then outside the square root was the plus 5. So here's what, oh shoot, I always hit that wrong thing. Let me type it in here again. Y equals 3 root x plus 5. So there we go. Oh shoot, that's not right. Equals. That's better. Now let's shrink him. So there's your graph right there. We can clearly see that he passes the horizontal line test, so he should have an inverse. Now I'm going to graph what we found for the inverse, and I'm going to do the simple form we had, the in parentheses, equals. In parentheses, I'm going to put the x minus 5. In parentheses, I'm going to square that, and then the whole thing divided by 9. So you can see the what I think is the inverse, but there's too much there. That's the entire parabola. And really all we want is the right-hand side of that parabola. We got to get rid of the left. Now, trying to figure out where to get rid of that left at, we just have to look, and it's right there. This equation, the original one, ends at 0, 5. And so our inverse should start at 5, 0, the reciprocal of that. And if I find the vertex right there, x is 5, 0 is the corresponding point, or the point of symmetry with the other one. The other one had 0, 5. This one has 5, 0. Notice x is 5. So we want to limit the domain of our function, our inverse function, to just x has got to be greater than or equal to 5. And then it will just be from the vertex to the right-hand side of that parabola. Now, I can show that in my Desmos here. In Desmos, to restrict your domain, you use a little bracket afterwards. And I said I want my x's to be greater than or equal to 5. And that should do it for us. And now you can see, yes, those two are exact mirror images about this line, y equals x. And let's see if we can make that line dotted. There we go. Make that a dashed line. So as long as we restrict our domain, then that is the true inverse function of the original. All right, let's close down our graph there, and let's finish these up. In problem 13, it says to graph the function to determine if it has an inverse, or sketch a graph of it. So let's grab Desmos again. Let's get rid of some of this other stuff. Turn those things off. And let's just graph y equals, and it's negative x cubed. Oops, that's not a cubed. There we go, negative x cubed and then minus 9. So there's our original function. Zoom him a little bit. Looks like that. If we got to sketch him, we want to note one of the key points. It looks like right here, and hopefully it'll pop up there. 0, negative 9, that's a good point. And that also crosses at about negative 2 in the x. So if I'm graphing number 13, just making a sketch of 13, it's going to look something like this. I'm going to put a mark down here, label it negative 9, and at about negative 2. Switch colors here to draw our graph in. It just does something like this. I missed a little bit. But something like that graph. And now this graph does pass the horizontal line test. Okay, I can, any place I draw a horizontal line, it will only hit it in one point. So yes, we're going to say yes. Inverse is a function. I don't even put the reason why, because f of x passes horizontal line test. That's the reason why we know it has an inverse function. Okay, so that's our first thing to answer. Now we can go ahead and find out what that inverse function is. So let's go ahead and create a little workspace here. And let's find the inverse of f of x. So here's f of x. Let's do the change in notation. So f of x we change to a y. Let's replace our y with an x and our x with a y. Let's isolate the y by adding 9 to both sides. That y is not by itself yet. It's got this darn negative in front of it here, so I'm just going to multiply both sides by negative 1. Now it switches everybody's sign. And now you can cube root it. Giving you y equals cube root of y cubed is just y, and the left-hand side, we just leave it underneath that radical. The cube root of negative x minus 9. Let's go ahead and take a look at that on our graphing calculators to see if it does look like the inverse should look. So there's our original function. And now I'm going to graph what I think is my inverse, y equals. Now I've got to do cube root again, but again, I don't know how to do that. So I'm going to put negative x minus 9. And I'm going to raise it to, instead of cube root, I raise it to the 1/3 power, which is the same as cube root. So there it is. And let's take a look. Yep, those two are just beautiful reflections about that line, y equals x. And so we're in really good shape. Very last one now, I think, because that was 13. We have to do 14 now. Let's take a look at 14. 14, I just don't want to stop at number 13 because that seems like bad luck. And so I thought, let's try just a little word problem here. I am 4 times as old as my daughter. So let's make the daughter D equals daughter's age. And that's our age right now. And my age is 4 times that. My age is 4D. In 20 years' time, I'll be twice as old as her. So in 20 years, my daughter will be D plus 20. Oops, it's a terrible looking 20. That's my daughter's age in 20 years. It'd just be if she was 5, now she's 5 plus 20, 25. I'll be twice as old as her. So in 20 years, my age was 4D. Now it's 4D plus 20. That's my age in 20 years. And they say that will be equal to, it'll be twice my daughter's age at that point. So I can write a little equation that twice my daughter's age in 20 years, that will equal my age in 20 years. And there's our equation that we can solve. So let's do a little distributing. 2D plus 40 equals 4D plus 20. We'll get our d's on the same side, so let's subtract 4d. Negative 2d, and let's go ahead and throw that 40 over there. Equals negative 20 divided by 2, my daughter's age. That's my daughter's age now. That's what I defined d as at the very beginning. Negative 20 divided by 2 is 10. So my daughter, how old are we? So right now, the daughter must be 10 years old, and I'm 4 times the daughter, so I must be 40 years old. Let's check in 20 years. In 20 years, my daughter will be now 30 years old, and in 20 years I'll be 60, which is twice my daughter's age in 20 years. So currently, I'm 4 times my daughter's age. In 20 years, I'm twice my daughter's age. And that's it. My daughter right now is 10, and I'm 40.